So for 60.1 question 10, you don't have to worry. Exam, I won't ask you to prove like that. Okay, but I will prove it. I will prove it to you how we get the answer. You want me to prove part A, is it? Okay, huh? So I'm going to prove part A. I'm going to start with left hand side. Okay, left hand side is sum of I equal to 1 to n xi minus mean square. Okay, so that is the question. So I'm going to break this to plus. So I'm going to put it like that. The first one, x1 at the bottom means the data number 1. Okay, take away the mean square. Plus the second data, the whole thing square. Plus many more. So I put dot. And the one before n will be, the last one will be xn minus mean the whole thing square. So that is how you interpret the meaning of this word. So this symbol is summation also. So you see integration also is summation. This one is also summation. Okay, sum of. Yep. Okay, so now I'm going to expand one by one. Okay, I'm going to expand one by one. So the first one is x1 squared minus 2 times x1 times mu plus mu squared. So this is the first expansion, correct? Plus the second expansion will be x2 squared plus mu squared. Then plus many more. They are all together, n of them. Then the last one will be xn squared minus 2 xn mu plus mu squared. Okay, so all these, I'm going to group them into 3 different groups. This is the first group. So I'm going to put it like that. x1 squared plus x2 squared plus dot xn squared. So this is the first group. So the second group will be the takeaway. Right? So I will put it like that. Because there is a minus in front. So I put a minus. And you see everyone, they have a 2 and a mu. Am I right? So I will factorize out 2 mu. There is a mean of the population. Open bracket, x1 plus x2 plus the last one, xn. So this is the third group. Can or not? Okay. Plus, everyone, you have the third one, mu square, mu square, mu square. Am I right? So I'm going to put it as mu square plus mu square plus dot, everything is mu square. So how many mu square do I have here? How many mu square do I have here? N time of mu square, am I right? Hello? Okay, so now x1 plus x2 plus x3 plus xn. What does it represent? Okay, so I'm going to write down in symbol form now. This is sum of xn squared, xi squared, I equal to 1 to n. Okay, take away 2 times of mu, and this is sum of xi, I equal to 1 to n. Am I right? Plus n mu squared. Okay? So now, we know that mu is equal to sum of xi, I equal to 1 to n divided by n. Am I right? You know this fact, am I right? So therefore, sum of xi, I equal to 1 to n is equal to n mu. So can I replace this with n mu? So I put into here. So I got the answer. Are you okay? So I got the answer. So I have sum of I equal to 1 to n xi squared minus 2. This is 2n mu squared plus, take away 2 plus 1. So I left with n mu squared. Done. 2 take away 1. Negative 2 plus 1 is negative 1. Okay. So are you okay? So that is how they come about the formula of standard deviation. So equal to the right hand side. So you for this question, you must try to prove from left hand side to right hand side. You cannot do it the other way around, you go crazy. So sometimes proving is, you have to see expansion is easier than factorization. Am I right? That's how you go. Expansion is easier than factorization. Yes, Haoshen, why? Can I take it at the end? Is attendance more important or learning more important, Haoshen? Okay, you say so. When will you take the measurement of mode as important for that situation? Like for example, if I produce, okay, if for example I'm a restaurant owner or bakery owner. So what is important? I want to know how much each product was sold from the history, correct, every day. So the one with the highest frequency, I should produce more, correct? I should bake more of that, correct? Like I have 3 types of bread, A, B, C. A is the mode. So in that situation, mode is a satisfactory measure. Are you clear? Like for example, I'm a factory owner for shoes, produce a shoes. So what should I look for? More shoe size, correct? More people are having the shoe size, so I produce more of that lah. Am I right? So mode will be a satisfactory measure for that situation. Like for example, I'm a teacher. When I get my student mark, which is more important? Satisfactory to me, the mean. Correct? The mean will be a satisfactory measure, so that I expect my student, most of them will, they will get this mark. I expect them to get this mark. So if you get below that, then you are called below average. You know your standard. right? Then when do I want the median? Median is talking about 50% of the population, right? And what is the difference between median and mean? Mean, you take every value into consideration, but median you don't. So usually median is unless you want to know the percentage of people who get above and below certain mark. So do you see? That is the meaning of satisfactory center measure. It's very situational. So you have to study the situation. What is the objective for that situation? Got it? Okay, done. Population standard deviation. The symbol is this one, right? Okay. So if you want to talk about variance, okay. How Kevin, go to your textbook, page 172. You can get variance. You cannot get variance from your graphic calculator. Your graphic calculator only show you standard deviation. Now you tell me, what is the relationship between variance and standard deviation? Look at page 172 of your textbook. There is no symbol for it, correct? Population variance, they write it as. So you tell me how to find population variance. The standard deviation of the population, the formula go in this way, am I right? There are two formulas, correct? I would prefer to use this formula. Easier to use if you need me to count manually. Okay, if you use your graphic calculator, you key in the data, then you straight away second mode, quick from there, then you go to one vars, go to calculate and one var stack. Am I right? Press the button stack, then you go to calculate one var stack. So whatever you get is just the standard deviation. So you see, this is standard deviation square, correct? So there is a variance. That's it. Whatever given by the calculator, you square it. Your calculator will not give you the variance. I told you already yesterday, variance has no meaning. It's just want to get it off the negative side. That's why every standard deviation formula must have the square root. Right? Okay, are you okay? Yeah. Standard deviation you can go get from GC. I hope everyone know how to get from GC. You better learn how to use your GC effectively. Optional or not?